Okay, welcome to Flip Math, Day 1. This is Mr. Zacek here, and get happy. Clap along if you feel like happiness is the truth. Today, what we're going to look at is arcs, semicircles, and central angles. And you should have notes in front of you just to give you a little direction. What we'd like you to do is fill through your notes. We're going to be checking those. And write down any questions that you have as we go through this material here today. So, as we look at this first slide, what we're going to see is the sum of the measure of the central angles of a circle with no interior points in common is 360. Okay, so when we have a circle, a central angle is an angle with its vertex at the center, and it separates the circle into two arcs, what you see here in front of you. And the sum of the measure of the central angles is in common, but what we want to notice here today is the key to a central angle is the vertex, which is here at the center. I probably need a little different color pen here. Okay, so we see this angle here is the same as the intercepted arc. So we have this arc going on right there, and that angle, those two are the same. And that is the big thing that we want you to get. The measure of the central angle equals the measure of its included arc, or sometimes you'll say intercepted arc. Now, one of the questions that you can ask is, well, how do we know what it means for the included arc? And the way that you can identify that is go to your vertex and follow the two sides of your angles out to the side. Where does that hit the circle? In those points where it hits the circle, that's what we're talking about when we say that it is an included arc. So the angle's 115, the central angle, the included or the intercepted arc is also 115. Now, as we look at this question here, name the smallest central angle. And we're going to see that we have how many central angles do we have? Well, where is the center? And the center in this case is point C, right here. That's our center. Well, I've got an angle here, I've got an angle here, and I've got an angle, we'll use two lines there, an angle here, we'll use three. And which one of those is the smallest? And so we remember when we're naming angles, we're going to call this angle A, C, B. Okay? And remember, that middle letter is always the vertex, or where the two sides come together. And in a central angle, that vertex needs to be at the center. So if you're going to have a central angle, you better have the middle letter be whatever the center is of your particular circle. So, how can we apply that? Well, if with a measure of arc BD, now let me point out here that arcs can also be named with a little symbol, that's the arc symbol. So we could call this, instead of writing the word arc, we could call that arc BD with a little curved line above it, is 160. So let me get my highlighter, and on this diagram, I'm going to mark out, whoops, that's not the highlighter, arc BD. Okay, so arc BD is 160 degrees. The question is, what is the measure of angle DCB? Well, DCB, let's find where that angle is. D, start at letter D here. C is the vertex. B is out here. That's the angle. Okay, well, if I follow that angle out to where it hits the circle, I notice this is a central angle. So here's our concept. We want to think central angle equals the intercepted arc. So therefore, if this angle is 160 degrees, the measure of angle DCB will also be 160 degrees. Again, the central angle equals the intercepted arc. So one of the things that we have to keep in mind, and it's something that we all know, is the measure of an entire circle is 360 degrees. And we have a couple different types of arcs that we'll see here in this. We will have a major arc and we will have a minor arc. Now, a major arc is going to be an arc that's bigger than 180. So if we put in a couple radii here, and let's add another letter over here, let's call that C. In this case, we're going to have a minor arc, which we'll use two letters to represent. Less than 180 is going to be AB, arc AB, and so we use that symbol. So with minor arc, we want to think, okay, less than 180 degrees. Now our major arc is going to be bigger than that. It's going to be greater than 180 degrees. And here we're going to use three letters. So if we follow along here, if I start at A, it's going to go through point C and end at point B. That would be a major arc, and I would use three letters. I would call that arc A, C, B. Or if you want to flip the letters around, very similar to what we've done earlier in the year with segments, we could call that BCA. All right. And then we have the last part there is an arc formed by a semicircle is 180 degrees. So if we were to, let's say we extend this line here, and that's a diameter, and let's call that point D, okay, and we could say the measure of arc BCD equals 180 degrees. All right, and that's going to be very helpful to remember, because we're going to start needing some information along the way, and this is one of the things that we want to keep in mind, that half of a circle is 180. Okay, and we call that a semicircle. So in this case, name a minor arc. Now again, here we have a couple different minor arcs. One of those could be, we could call DA a minor arc. Arc DA. Or maybe we want to use AB. We could call it arc AB. And again, we could switch those letters around. And actually, as we see here as well, this arc from D to B, that's also less than 180. So we could call arc DB a minor arc as well. So we have a few different minor arcs that we see in here. Now when we want to do a major arc, we're going to need three letters for this. So what would a major arc be? Well, we could say, let me get the highlighter here again. Let's say we start at A. We need to be more than 180, so we're going to be A through D to B. And so we would call that arc A, D, B, using three letters. Or we could flip it around and we could call it B, D, A. And there's different options that you have if we didn't want to. We could go DBA. That's another option that you could have. DBA. That's more than 180. Um, you have some different things as we look at those. Okay, so next thing that we have here is called the arc addition postulate. And it says this: the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Now that's very straightforward, just like early in the year when we did the segment addition postulate. And here is what it says: the measure of those two adjacent arcs. And remember, that word adjacent means next to. Like, the person sitting next to you is adjacent, or your neighbor is adjacent to your house if they live next to you. And so we see here in the arc addition postulate that when you add those two together, they equal the sum of those. So here, given circle P, if we look here at this example, the measure of arc BA, and that should be an arc that kind of looks a little more segment-like. The measure of BPC is 735. Find X. Okay, now what we want to remember here is that the central angle equals the intercepted arc. So we have a central angle here at P. And that's what it means when it says circle P. It means the center is P, at point P. So, central angle. This arc here is 75. So this angle is going to be 75. This arc is X. So that central angle is going to be X. Now, we also know BPC. Okay, that angle here is 135, and that means those two arcs added together are also 135. So the way that we would write this is the measure of arc BA plus the measure of arc AC equals 135. Now we can substitute into that. This is going to be 75 degrees. We're going to call arc AC X, and we want to equal 135. So we subtract 75, and that leaves us with 135 minus 75, which is 35 and 25, 60 degrees. Okay. So X is going to be 60 degrees. So again, the key here is recognizing that we can add those together and the central angle and the arc are the same. Okay, next example. DA is the diameter in circle O. Okay, so that's a key term for us. In circle O, again, recognize when they say that, that means the center of the circle is point O. We're given some information. If the measure of arc CD equals 20 degrees, and the measure of angle COB equals, so here we go, COB equals 85 degrees, then find the measure of angle BOA. So let's call that X. Now, what we see here in what we're given, our information, is that DA is a diameter. So I'm just going to, kind of use my segment tool here and draw that in. DA, that's a diameter. Now, I need to see in this that the arc that I gave, CD, is intercepted by that central angle. So that central angle right there is the same as that arc. 20 for the arc, 20 for the central angle. The vertex is at the center. Now, as I look at those three angles, what do I notice? Well, hey, we got ourselves a semicircle. Or I can see this as a line. And all of those angles, whether you think of that as a line or whether you think of that as a semicircle, if we want to work our way out here outside the circle, it's going to be 85 and it's going to be x. Again, central angle, intercepted arc, they're the same. All of those together are going to add up to 180. So we can write a nice equation here. We combine like terms. We're going to subtract 105 from both sides, and we get 75. So the measure of angle BOA is 75. And again, it didn't matter whether you think of that as arc BA or angle BOA. In both cases, we come up with the same conclusion there. Okay, so looking at another example. Here we are again. DA is the diameter of circle O. So we have a diameter, circle O, that tells us that's the center. All right? It's going to be key as we think about central angle. Given the measures as indicated, find arc CDE. Now, what we've done is we've drawn in for you here what we're looking for. So you need to see, wow, that's a couple different angles put together. So we just want to work our way around a circle. Now, we see that we're given that DA is the diameter. Okay? So that's very important, as I mentioned earlier. That tells us we have a semicircle. So as I look at this, I see, wow, this arc here, DE plus AE, that's a semicircle. So I can write a little equation. The measure of arc DE plus the measure of arc AE, that's got to equal 180. So the measure of arc DE plus 80 equals 180. And writing it out like that really is a great way of communicating that we really know what's going on here. So measure of arc DE is 100 degrees. Well, we should notice that this angle is 100 degrees as well. Central angle, intercepted arc. Over here, 80 degrees. 80 degrees for the central angle. 70 degrees for the central angle. This box right there, that's a right angle. We know that's 90 degrees. And look at that. If we follow up the lines to B and C, we have 90 degrees. Now, what do we got going on this side? Well, we still need this little piece here. We haven't found arc CD, but here again we have another semicircle, and it's the measure of arc CD plus the measure of arc CB plus the measure of arc BA. All of those add up to 180. You got to be careful, I'm sneaking into the other ground. Okay, so the measure of arc CD, that's what we're trying to find, plus the measure of arc CB, I see, oh, that's 90 degrees. The measure of arc BA, that's 70, equals 180. So the measure of arc CD, we're going to combine like terms, 90 plus 70, 160 equals 180. We're going to subtract from both sides 160, and arc CD is going to be 20. So this is 20. This angle here is going to be 20. And now our final answer, what are we looking for? This yellow line, follow it along here, CDE. Well, that's 20 plus 100. So we're looking at 120 degrees. Okay? So, a little bit of work, but we want to use those things. What do we have? Where's our diameter? Where are things 180? Recognizing again the central angle and the intercepted arc are the same. Okay? So here we go again. Another very similar type of thing. We have a diameter. We got circle O. Hopefully by now we're recognizing that that's the center. Here's our diameter. And we have angle COD and angle AOE are vertical angles. Okay, that's a term from earlier in the year. And one of the connections we want to make with vertical angles is that they are congruent. So COD, that angle, and angle AOE, those are congruent. So we got a couple diameters there. The measure of arc BA is 70 degrees. So this angle here, BOA, is also going to be 70 degrees. Now we see our right angle marking here, and what we should recognize is, okay, those two together are 90. So 90 minus 70 is going to be 20 degrees. So what do we got here? That angle's 20. If angle AOE is 20, arc AE is also 20. What do we look at? Vertical angles, they're congruent. If this angle's 20, this angle's 20. If that angle's 20, this arc is 20 degrees. All right, we're really making a lot of progress now. All right, and again, let's get to what we're looking for. We're looking for the measure of arc DE. Well, here again I see I have a diameter that forms a semicircle, half of a circle, and so I've already got that one part. So the measure of arc, well, excuse me, that's the wrong color that I want to use there. The measure of arc DE plus the measure of arc AE equals 180. So we substitute in, we know the measure of arc DE, okay, or excuse me, we're looking for that. We know the measure of arc AE is 20, that equals 180. So when we subtract 20 from both sides of the equation, it's 160 degrees. All right, 160. So just kind of working our way around. Then we could write it in here, 160 and 160 again. Really highlighting today the central angle, the intercepted arc are the same. Okay, one other one like that. C, E, and DA are diameters in circle O. So we've got a couple diameters. OG is the angle bisector of angle COB. All right, now if I recognize this angle, let's identify that on our diagram. Okay, so we have angle COB, and what do we have? OG is the angle bisector. All right, when something is being bisected, we're going to say that's cut in half, or creates two congruent angles. So those angles there, they're going to be the same. If the measure of arc CD is 15 degrees, find the measure of arc GBA. And again, you see that with the yellow marking there, that's what we're looking for. All right, well, let's just kind of work our way through. 15-degree arc at GD, that means this angle is 15 degrees. Sorry if that looks a little off to you. What I'm seeing here is I'm seeing this diameter here, and I'm seeing these two arcs are the same. So what I'm going to do is I'm going to call those two, Got the highlighter again when I need the pen. Um, Let me get my pen back. Get a little bit of a thinner line for you. I'm going to call this X and this X. Now, they're the same, and so therefore these arcs will both be X. That diameter, it's a semicircle, so it's 180. So what we can do is X plus what's this other angle? 90 equals 180. So we solve that equation. We're going to get 2x plus 90 equals 180. When we subtract 90 from both sides, we get 2x equals 90. When we divide by 2, we get x equals 45. So this angle is 45. This angle is 45. That means the arc is 45, and this arc is 45. Have we found all that we need yet? And the answer is no, we haven't. We're still needing to find arc BA. Well, this is where we start, having to just really keep ourselves focused, because things can get a little confusing if we're not really paying attention to the detail. Now I have a new diameter there. And I know that this is 15, I know 45, 45, and that remaining part is going to be arc BA. So I'll begin to write that down here. Okay, the measure, whoops, get my pen. The measure, the measure of arc BA plus 45 plus 45 plus 15 equals 180. And so the measure of arc BA, all right, as we combine like terms, 45 and 45 is 90, plus 15 is 105, 180. Okay, when we subtract 105, the measure of arc BA is 75. Okay, so arc BA is going to be 75. Now, to get GBA, we want to add those two together. So 45 plus 75, okay, is 120 degrees. All right, and we've got some more, but I think at this point well, now let's do this one more, and then we'll call that good there. Okay. All right, here again we've got a diameter, circle C. This time we have a different center. Okay, C is the center. So as we look at our diagram here, we see what we're trying to find. That's in yellow. We see what we know. 45 central angle is also going to be 45. 60 central angles also going to be 60. Now it's the diameter. TQ is a diameter, so that's a diameter. It forms a semicircle. They're going to add up to 180. So here it is, the measure of arc. Keep messing that pen up. The measure of arc, TP, or we could call it TRP, plus 60 equals 180. Okay, there's your semicircle. If you can't see that, I'm just going to highlight it for you. Okay, we're going to add those two together. They're going to equal 180. Now, when the measure of arc TRP, when we subtract 60, we get 120. So this arc is 120. This angle is 120. All right, what are we trying to find? 45 plus 120 equals 165 degrees. And there you go. All right, so hopefully that helps you. If you need to go back and rewind and look through those things, but again, the real connection that we want to make is that those two are the central angle and the intercepted arc are the same. Um, Good luck as you're working through your practice questions.